Today, we will present you a new way to interact with remote sensing images. My name is Sylvain Lobry, and together with Diego Marcos, Benjamin Kellenberger and Davis Tuya, we worked on visual question answering for remote sensing, a new task that aims at answering natural language questions asked about a remotely sensed image. Indeed, people have questions about their environment. In many cases, the answer to these questions could be found in remote sensing images. However, if you do not have an off-the-shelf model that has been designed to answer your precise questions, extracting this information is hard. Let me give you an example. I was wondering how many sport fields are there in Esa Frascati. To automatically answer this question, you would need to have a football pitches detector, a tennis pitches detector, as well as any other sports field detector, as you cannot assume that only these two will be present. Because the questions that people might want to ask are open-ended, it is not possible to use algorithms designed for a specific task to answer any question. What we would like instead is a single model that given one remote sensing image and one question in natural language would give an answer also in natural language. To design and train such an algorithm, we need a dataset. Our goal is to obtain many image question answer triplets. For a given image, we can automatically generate many questions. These questions are generated randomly in both a text representation and a true representation. For example, on this image of Amsterdam, we can ask, are there more buildings above a circular religious place and roads in the image? While images are nowadays relatively easy to obtain and questions can be generated automatically, but within the true answer is tricky. To get the answer, we leverage open data from OpenStreetMap. First, we retrieve the OpenStreetMap data corresponding to the extent of the image. We can then pass the true representation to get the answer. The first element is religious places, and there are two, highlighted in red on the map. Then we are interested in the shape of these places, in this case circular. We want to compare two buildings which are above, so we first retrieve the building, and then select those north of the religious place. Finally, we can compare the number to the number of roads in the database and get the answer to our question. We created two datasets. The first one is derived from Sentinel-2 images and contains 77,000 questions. The second one is made of higher resolution images and contains close to 1 million image question answer triplets. You can download these datasets on this project's website that you can access at rsvqa.sylvainlobry.com or by flashing the QR code. On this website, you will also be able to download the code of our models. We propose two deep learning-based models. For the first one, published early this year, we reframe the visual question answering task as a classification one. Our goal is to predict the most probable answer to a question among a set of predefined ones. If you want to know more about this method, I invite you to read the article that you can access by flashing this QR code. For the second model, also based on deep learning, we took a multitask approach. We predict an answer among a set of predefined ones, but also a number for numerical questions. Indeed, the classification approach shows limits for such questions. Finally, we also predict the relevant type of answer, among set or numerical, based on the question alone. Once again, you can read more about this approach in our publication that we just released. We can now have a look at three visual results. In the first one, the question is there a residential building at the bottom of a place of worship? This question involves spatial reasoning in addition to object recognition and shows that natural language is a relevant interface for this kind of complicated questions. The second example, on the opposite, shows a case on which natural language makes the problem ill-posed. Indeed, while the question is about the number of buildings, this object does not have a strict and universal definition. Therefore, both answers, 3 and 1, could be correct. Finally, the last example, how many buildings on the left of a road are there, is a failure case of our model and shows that there is still a lot of work to be done. In conclusion, we have presented a new task in the remote sensing community which could change the way we access remote sensing images. Visual question answering for remote sensing. There is still a lot to do and you can participate to the development of this new task. We release both our codes and datasets on our project webpage. I would like to thank you for your attention and I am available to answer your questions.